Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is 3-chloropent-4N3. Wait, let us reread. The central carbon has 4 substituents, CH to CH3, H, Cl, and CH is equal to CH2. This is a chiral carbon, all 4 groups different, making it a single stereoisomer, one enantiomer as drawn with H on the left wedge implied. Step 2. Identify the reaction. HBr adds to the vinyl group, CH is equal to CH2 via electrophilic addition, Markovnikov addition. HBr adds across the double bond, H adds to the terminal CH2, less substituted, and Br adds to the internal carbon, more substituted, Markovnikov, generating a new stereocenter at the carbon that was CH is equal to CH2, now CHBr, CH3. Actually the carbon bearing Br. Step 3. Analyze stereocenters in product. The original chiral carbon, bearing Cl, retains its configuration, no bonds to it are broken. The addition of HBr to CH is equal to CH2 creates a new chiral center at what was the internal alkene carbon. Since HBr addition to a double bond proceeds via a carbocation intermediate or without stereospecificity in CCl4, the new chiral center is formed without stereo control, giving both R and S configurations at the new center. Step 4. Count stereocenters in product. The product has 2 stereocenters, the original carbon, fixed configuration, unchanged, and the newly formed carbon from HBr addition, formed as a mixture of R and S. Since the original center has a fixed configuration and the new center is formed as R and S, 2 products are formed that are not mirror images of each other because the other center is fixed. These 2 products are diastereomers of each other. Step 5. Why other options fail? A. Racemic mixture would require equal and opposite enantiomers, not the case here since one center is fixed. B. Optically inactive implies either meso or racemic, not applicable. D. Meso requires internal plane of symmetry. The 2 stereocenters have different substituents, so meso is not possible. The 2 products formed are diastereomers. Therefore, the correct answer is C. Therefore, the correct answer is option C.